Very good afternoon to all of you. Welcome to today's live coaching classes. To the measures of central tendency. Firstly, the central tendency will be a descriptive summary of a database, and it reflects the center of the data. So we shall be understanding the concept of central tendency. Now, please note that there are three means, three ways, three parts of central tendency. First measure is mean or the average. Second is median. And the third is known as mode. So there are three parts, three types, which we will learn one by one. Today we are learning mean and median. And on the next day, we shall be understanding the concept of mode. Okay. Firstly, let us look at arithmetic mean, the first type of central tendency. So here, what is arithmetic mean? Now, let me first share the types of tendencies we have: arithmetic mean, median, mode, geometric mean, and harmonic mean. Now, arithmetic mean is simple average. So if I take an example here, and if I say that there are some people have, I'm just sharing the scores of some some people have got some marks, and say the scores are like this: 50, 64, and say 70. 50, 64, and 70. Now we want to know what is the average performance, what is the average score. So to find out the average score, what we are doing, the arithmetic mean, you know, we just add 50 plus 64 plus 70. Okay, let me have one more. Say let there be one more performance. So we have, say, another person, someone has got very good marks. Say it is 88. So we have someone at 50, 64, 70, and 88. So if I want to find out what is the average score, so what will I do? We will add. First, we are adding. So let us add these numbers and find out what does it lead to. Okay, and then we will find out the average by dividing. So you know how to find out the average. First, by understanding, first we will just add up. So 50 plus 64, 50 plus 64 plus 70 plus 88. So I'm getting a total of 272. 272. Now this will be divided by number. How many people are there? 1, 2, 3, 4. 4 people are there. 4 scores, 4 numbers. Therefore, we will divide it by 4 and we are getting 68. So this 68 is the arithmetic mean or the average in this case, in this example. Okay. Now, let us see the next part. Okay. So, definition of mean. So, it is the average of a group of numbers. Please note, mean is the average of a group of numbers. So, let us see the example here, 25215. Okay. I think I'm audible right from the first, because many people are writing not audible. I was audible right from the first. Just check. You can see the video once again. Okay. Okay. So I'll just make a recap. So we were discussing about the types of central tendency, and we have covered, let's just going to the last few slides. So central tendency, as I was mentioning, is the descriptive summary, and the example, the central tendency means the tendency or the nature of observations to cluster around the central part. So as I said that when we talk about some, say, the scores of some students will get extremely high scores. In a class, for example, when we are trying to find the height, some people are very tall. So maybe 5 feet 10, 5 feet 11, 6 feet. Some people might be short. So some people might be around 5 feet. So the average height will be, say, somewhere around 5 feet 7. So that gives you the central tendency, neither on the higher side, neither on the lower side, but somewhere in the middle. So this is known as central tendency. And there are different methods of finding central tendency. And one is mean, the other is median, and the third one is mode. Okay. So now we will understand what is mean, and it is the average of a group of numbers. The average of a group of numbers. So if you see 25215, okay, 25215. So how do we get the mean? Let us just work it out, the simple examples, and then we will understand the concept. So 25215. So you just add up 2 plus 5 plus 2 plus 1 plus 5. So 2 plus 5 first plus 2 plus 1 plus 5. So when I'm doing the sum, I'm getting 2 plus 5 is 7, 8, 9, 10, and 15.
Recording in progress.
Find out the mean, that is, once you get the total sum, the sum comes to 96. The sum comes to 96. And how many numbers are there? 1, 2, 3, 4, 5, 6 numbers. So you divide by 6, 96 by 6. That gives you how much? That gives you 16. Okay. So you can see it comes to 16. 96 by 6 gives you 16. Okay. So we can get, in this way, we can get the average. Yeah, many of you are doing it, yes. Some people might be getting problems, but some people are, they are saying there is some audio problem, but I checked it with the technical support here. There is apparently no audio problem. I'll just check. Yeah, am I audible? Can you just check? Technical support team. Okay. Because students are writing that audio is not, they are not getting the audio. They are saying that it is mute, but I think audio is clear, isn't it? Okay. They may have some problem at their end. Okay, right. Chalo, let's move on, because technical support team has just confirmed that audio is okay right from the beginning. So some you might be having some problem at your end also. Okay. Now let us look at mean. The mean represents the average value of the data. So we can see that we are looking at, say, if you take one more example, someone has got, say, 50, someone has got 60, someone has got 70, and a topper has got 90. So 50 plus 60 plus 70 plus 90. So when we find the average, so it comes to 110, 200, 270 divided by 1, 2, 3, 4. So 270 divided by 4. So I'm getting 4 6 are 24, and say 4 7s are 28. So around 67. Say, let us take it as 67 approximately. So we are taking 67. Fine. Now 67, please note that it is the average value of the data set. So 50, 60, 70, and 90, we are getting a score of around 67, which is the average. So it is the sum of the entire values in the data divided by the number of values. Now let us take an example here. Let us take the example of, say, Virat Kohli. Now you can see there are a number of, we have in this table, you will find quite a number of data. You can see there are some numbers, runs, the runs which Virat Kohli has got. Now the arithmetic mean, if you see the arithmetic mean, okay, so if you look at the arithmetic mean, you will find that the score comes to the total innings 1, 2, 3, 4, 5 till 10. If you see the total number of runs which Virat Kohli has scored in this 10 innings comes to 661. So the average comes to 66.1. So 661 divided by 10 gives you 66.1, which is the average. So this is basically arithmetic mean, which shows the beginning. We are adding all these numbers and we are dividing it by the number of terms. So we are getting the average score, which is mean. Now, the criteria. Now you have to note that arithmetic mean, any mean for that matter, any average score like geometric mean or say harmonic mean or median or mode, it should be properly defined. So this can come as a question also as an MCQ. It should be properly defined. Number two, it should be easy to comprehend. That means to understand, like arithmetic mean is an easy concept. It is not difficult to understand. Number three, it should be simple to compute. That means for the calculation part, it must not be very difficult to continue to compute. And number four is it should be based on all observations. Okay, it should be based on all observations. That means when we are looking at the average, we have taken this average 50, 60, 70, 90. So we have considered all the numbers 50, 60, 70, 90. We are added up and then we are getting 270. So we are considering all the observations. And it should have certain desirable mathematical property, which we will see later. So these are the criteria for ideal measure for any type of central tendency. Okay. And if you have extreme observation, for example, in case of in case of arithmetic mean, after 90, if I have an extreme observation, say I add, there's one person who has got just 10. What happens when I add this 10, this 270 plus 10, the total becomes 280, and then I divide by 5 because there are now 5 scores. So 280 by 5 gives me how much? So 5 5s are 25 and 5 6, 56. So automatically you can see the original average was 67 and now the average has come down to 56. Why 56? Because one extreme observation, that is 10, just because of adding one extreme observation, the average has come down from 67 to 56. So this is the problem with certain types of central tendency measure like arithmetic mean. So these are the criteria. So it should be easy to understand, easy to calculate. It should be based on all observations, and therefore it should be desirable. These are the desirable qualities, and this will be used, okay, for our understanding. Yeah, harmonic mean, there is one question. Bhumika, harmonic mean we are going to do later on. We are going to study on 18. Okay, so today we are focusing basically on the introduction to central tendency and arithmetic mean and median. So now we look at, there are three types of mean. We have seen AM, GM, and HM, arithmetic mean, geometric mean, and harmonic mean. And arithmetic mean, please note, is the most commonly used. So if a question comes, you will see that the arithmetic mean is the most commonly used. And the problem is with, you will find that when you get a problem on this question, that which central tendency measure is most commonly used, AM, GM, or HM, the answer is AM. And we will find there are some calculations which we need to do for all the three categories, both for AM, GM, and HM. There will be separate calculations. So arithmetic mean, when we are calculating, it is just summation divided by n. So say, for example, when we are taking some observations, say I'm just randomly taking 2, 6, 10, 13, and say 20. 1, 2, 3, 4, 5, one more I will take. So I'm taking, say, 31. So if I want to find the average, I will just add. That is, what I'm doing is sigma x, which you can see on the slide. I am adding all of them. So I'm getting 2 plus 6, 8, 8 and 10, 18, 18 and 13 is 31, 31 and 20 is 51, 51 and 31 gives me 82. So I'm getting 82 divided by 1, 2, 3, 4, 5, 6. So 82 by 6. So something, I'm getting something like, say, around 13 point something. Because 13, 6 is 78, so 13 point something, approximately. I'm just writing approximate sign. So here, the average is sigma x divided by n. N is the number of observations. So here the number of observations is 6. 1, 2, 3, 4, 5, 6. 6 observations are there. So that's the first formula, sigma x by n. Now we have to, this is an example, you can see 3, 6, 24, and 48. So we can easily find the arithmetic mean just by looking at the addition. We get the sum and then we divide by the number of observations. Here we have 4 numbers, 3, 6, 24, and 48. So therefore, we are getting an average of 20.25. Okay. Now, if we have frequency, second one is weighted. So this is simple because we have simple numbers here. There is no frequency. But what happens when there is a frequency? So we will just try to take an example to understand what is frequency in this case. So let us take this situation where we have a table. So I'm drawing a table here and there are some numbers. So I'm writing score and frequency. I'm writing score and frequency. So out of 10, say for example, there is a class test going on and some scores are given out of 10. The teacher has taken an exam and some scores are there out of 10. There are 10 students. Now, the scores people have got is say 5, 8, 6 and 2. Some people have got 2. Now, how many people have got 5? Okay, the answer is 3 people have got. 3 people you can see in the problem. How many have got 8? 2 people have got 8. 6, how many have scored 4? And there is one person who has got 1 out of 10. So this is the score. So you can see the score and the frequency. So in this situation, how to find the arithmetic mean? So the arithmetic mean, I'll just write it here. The arithmetic mean in this case, the formula will be sigma fx by n, where frequency is known as, the frequency is written as f, score is written as x, and the total number of students here you can see is n. Total number is n. So here we have 3, 4, 5, 9 and 10. So total is 10 and it's called n. So total frequency n is equal to 10. So now how to get fx? I will just multiply 5 into 3. So I will multiply 5 into 3 is 15, 8 into 2 is 16, 6 into 4 is 24, 2 into 1 is 2. So I am getting the total score here. 15 and 16 is 31, 31 and 24 is 55, 55 and 2 is 57. So I'm getting sigma fx by n equal to 57 by 10. And that gives me around 5.7. Okay, so in this way, we are able to find out what will be the mean when you have frequency. Okay. Now, Samir is asking a question, if mean comes in decimal, can we do round off in the exams? Now, please note, in the exams, you will be getting MCQ. You will get multiple choice questions. So first, please don't round off the score. Whatever mark, whatever figure you get, say it is 20.35, it is 71.9, say 92. So please don't round it off, because you may get in the multiple choice question, maybe 71.92 is one of the options. So please don't round off and look at the options. First, you look at the options and then you score. Then you write. Okay. One question has come. What is extreme? What is meant by extreme? Dhyanesh has asked the question, what is meant by extreme? Extreme means very high or very low. For example, please see in this case. Okay, you can also see that in the slide, on the slide, and also on this whiteboard. Please note here, if I ask you what is the extreme score, that means the high scores. Okay, very high is 8. The score is out of 10. Please note, it's a class test. It's a class test which has been conducted, and there are some people who have got scores. There are 10 students and they have got some scores. So if you look at the class test score, you find that some people have got very high marks and one person has got only 2 out of 10. So these are the extremes, very high and very low. Both are extremes. Okay, so that is known as extreme. And you will find that in case of central tendency, please see, one person has got 2, 4 people have got 6, 2 people have got 8, and 3 people have got 5. But the average score is coming to 5.7. 5.7 is what? 5.7 is very close to 5. And out of this scores, 5 is the central tendency, because 5 is the central part. Between 1 and 10, 5 is what? It is the center. It is exactly halfway between 1 and 10. So therefore, you can see the score is 5.7, which shows the central tendency. That means the average will always be somewhere around the central part. That is called central tendency. Yes, 2 is an extreme score. Yes, rightly said. Yeah, Ajitavo, don't worry. We will take up the missing frequency also. Yes, right. Now we will look at the ordinary frequency method. Let me take a table here. So let us try to find the mean daily wages. Please see the table which is coming up in the slide, and we will try to solve it, and then we will compare it with the answer. So you can see the mean wages. We have to find the mean wages is given. Okay. So you can see the wages is given 4 to 6 workers. Okay. And then you have 6 to 8 is 12 workers, 8 to 10, 17 workers, 10 to 12, 10 workers, and 12 to 14, you have 5 workers. Okay. So we will first try to find out the mid value. Okay. So 4 to 6, then you have 6 to 8, 8 to 10, 10 to 12, and you have 12 to 14. Okay, so this is you can see this is like a range. A range is given between 4 to 6. So we will first find the mid value. What is the mid value of 4 to 6? It is 5. 6 to 8 mid value is how much? 7. 8 to 10 mid value is 9. 10 to 12 mid value is 11. 12 to 14 mid value is 13. So this is the first working out we have done. Now the frequency is given, that is number of workers. 6, 12, 17, 10 and 5. 6, 12, 17, 10 and 5. So now if you see from these classes, this is a class. 4 to 6 is a class. 6 to 8 is a class. From these classes, we have first got the mid value, midpoint. Okay, the mid value. From the mid value, now it makes it easy, because now when I know the mid value, I can write this as X. This column which you see here, 5, 7, 9, 11 and 13, this is X. And this is the frequency column where you have 6, 12, 17, 10 and 5. Now what I will do, I will multiply X with F. So I'm writing F into X. So 6 into 5. So I'm writing 30, 12 into 7. 12 sevens are 84. 17 into 9. Let me work it out. 17 into 9. So it comes to 153. 11 into 10, 110. 13 into 5, 65. So now I will add it up. So we are getting 30 plus 84. Okay. So just let's add up and see. 30 plus 84. 30 plus 84 plus 153 plus 110 plus 65. So I'm getting 442. I'm getting the total I'm getting is 442. So if it is 442, then the daily wages will be how much? Please note the total number of workers is how much? The total frequency is 6 plus 12, that is 18. 18 and 17, that is 35. 35 and 10, 45. 45 and 5 is 50. So the total is 50. So the mean, the average is equal to 442 by 50. 442 divided by 50. So if you work it out, you will get something like, just work it out. I think some people have done it already, and you will find, just try to work out, and you will find that it comes to around 8.84. 442 by 50. 8.84. So this is a type of problem which you can expect in the exam. Short problem, not a very long one, but please remember the formula sigma fx by n. So here n means the total number of workers. In this case, the total number of workers is 50, and we have obtained the mid value, and from there we have solved the problem. This is easy, of course. We will slowly get into the more difficult ones, but we have to cover each and every part of the syllabus of the chapter given, so that you are absolutely clear about all the types of problems which can come. So I hope this is clear. Now let us take the next one and see what the next problem is. What type of problem we will do next. Okay, so I'm just going to the next slide. Okay, now we will understand shortcut method. Shortcut method. So here there is a concept of assumed mean. Assumed mean. Okay, and we will understand we will just look at the formula, And before understanding the formula, we will look at a practical problem to we'll do the working. And we will understand step by step how the assumed mean is taken. Okay. So let us take a practical example. And here it is. Compute the arithmetic mean of the following frequency distribution. Yes, many of you have got 8.84. Jyoti Jha, Mayur, Sarvesh, Priyanka, Bhumika. Yes, you have got 8.84. Okay. Yeah, Shivam is asking, can we solve it also using calculation? Yes, you can use calculator only according to the rules given in the exam. But when you are getting complicated problems, a calculator may not be useful to, you have to calculate at the end, definitely. But then you have to work out. Now, like for example, here, even using a calculator will not be primarily helpful. First, you have to find out the way in which you need to solve. You have to you have to complete one or two levels, one or two stages of computation. Then finally, you can use the calculator. But first, you have to simplify. Okay. Okay, let us take this one. Okay, Kami has written first class with you. I'm not a math student. Please try to just the support for you. What I can suggest is please go through the classes very carefully, and I will request you. This is from Kami Kindia. So please note that you need to practice from the mock test paper also, the mock test paper questions, and as well as all the questions in the study material and in the additional question bank. So once you do it, definitely you have a very good preparation and you will do well and you will definitely pass. Okay. Computing the arithmetic mean of the following frequency distribution. So here we will try to use something called, say, we will use the concept of assumed mean. So let us first write this and then we will understand. Okay. Now here you can see the questions is given. So we are taking, first you try to see the solution as we have done it. So we are first taking 54. First is mid value calculation. Okay, we will first calculate the mid value as we have done earlier. So it will be a very multiple table, very quite a few number of tables, 20 to 29 first, 30 to 39. Please note it is not continuous, 20 to 29, but then 30 to 39. 20 to 29 and 29 to 39. It's not like that. So it is 20 to 29. It is discrete. So I will use the word discrete. Yesterday in the last session, we had discussed about discrete distribution, discrete type of variable, a variable which takes specific values. But in case of continuous variable, it will take all values within a given range. Here you can see the value is from 20 to 29, but here it is 30 to 39. So it is not continuous, 29 to 30, that there is a gap. So let us just note it down first, 40 to 49, then 50 to 59, and then 60 to 69, and 70 to 79. So first let us find out what will be the mid value. Most important is to find the mid value. So we will do the mid value, step number 1. So 20 to 29, mid value will be 24.5. Because the difference is how much? 29 minus 20 gives you 9. 9 divided by 2 gives you 4.5. So therefore, 24.5 is the first mid value. Next, for 30 to 39, the mid value is 34.5. So I'm giving the heading mid value. 40 to 49, the mid value comes to 44.5. 44.5. 50 to 59, again 54.5. 60 to 69, 64.5, 70 to 79, 74.5. Now the frequencies are given 5, 11, 18. So I'm writing it 5, 11, 18. Then we have 22, 16, and finally 8. Okay. So please try to do it with me. Now we are going to take an assumed mean. Okay. So let us take the assumed mean and say this is the assumed mean. We are taking 54.5 as the assumed mean. Okay, so this is called A. 54.5 will be known as A. So now what we will do, we will find out the deviation. So the deviation will be x minus a. So now 24.5 minus 54.5. See, this is a. I'm just writing it here. This is the assumed mean. We are assuming 54.5 as the average, as the mean. So it is called the assumption. It is the assumed mean. So now how much do we get? 24.5 minus 54.5. I'm getting minus 30. 34.5 minus 54.5, I'm getting minus 20. 44.5 minus 54.5 is minus 10. 54.5 minus 54.5 is 0. And now on the increasing side, 64.5 minus 54.5 is 10. 74.5 minus 54.5 is 20. So now if I look at the total D, I have got deviation, and now what I will do is F into D. That is the frequency which I have noted here. This is the frequency and this is the deviation. F into D. So 5 into minus 30 is minus 150. 11 into 20 is how much? Minus 220. 18 into 10. 18 into minus 10, minus 180. Be very careful about the signs here. 22 into 0 is 0. 16 into 10 is 160. 8 into 20 is also 160. Okay, so now we add up. We have to find sigma FD. So if you add it up, you will get something like, let us just try it out, 320, and we have 320 positive. Here we have 580, 650. 650 and 320. So I'm getting, 345. Yeah, I'm getting 230 negative. 220, 300, 400, 550. Yeah, 230 is negative, minus 230. So we are getting minus 230. So the mean in this case will be how much? The mean will be assumed mean plus sigma FD by n. Assumed mean plus sigma FD by n. And here the assumed mean, okay, here the assumed mean is 54.5. So the ultimate computation will be like this. You can see A plus sigma FD by N. So it is 54.5 plus FD, sigma FD by N. Sigma FD is how much? Minus 230. So it becomes minus 230 by N. N is how much? The total frequency. So if you add up the total frequency, we are getting 22 plus 18 is 40, 51, 55, 55 and 16 is 55 and 16 plus 8. So you are getting the total frequency. If you see here in this problem, the total frequency, that is sigma f n equal to 80. Okay, so once you have the frequency 80, so it is minus 230 by 80. That means it is coming to, if you just calculate, it comes to 54.5, which is here 54.5 minus 2.875, that is, it's coming to 51.6. So this is the way in which you have to calculate arithmetic mean using assumed mean. Okay. One question, once more, please explain mid value. Okay, this question is from Sanket. Sanket is asking mid value. Yeah, some people have got 51.6. The first one of the first to get, I think 51.63. Archana, yes. Then Komalakshi has got, Shiba has got. Shiba, the FD is coming to 230, minus 230. If you see once again in the working out in the slide, you will see it is minus 230. Okay. So approximately 51.6. Mid value, Sanket is asking what is mid value. Mid value, if you see the class is how much? The class, the lower limit of the class is 20. Upper limit is 29. So what is the mid value? The middle point, the midpoint, that is the mid value. So the mid value will be half of this difference. The class interval is how much? 9. 29 minus 20 is 9. 49 minus 40 is 9. So if the class interval is 9 and you have to find the mid value, so 9 divided by 2, that gives you 4.5. Therefore, the mid value will be 20 plus 4.5, that gives you 24.5. In this way, we have got the mid value. So first is step number 1. Please note once again from this solution, that we have first got the classes are given. Okay, we first find the mid value. We have the frequency. We assume any of them as the assumed mean. Any of the midpoint, mid value, any of the mid value can be taken as assumed mean. So once you have the assumed mean here, you know the frequency. You find the deviation. Deviation will be what? Each of the variable minus 54.5. That is assumed mean. 24.5 minus 54.5. It comes to minus 30, minus 20, minus 10. In this way. And then once you multiply f into d, you are getting the complete sigma fd, and that comes to 230 in this case, minus 230. And then you can calculate the formula being, what is the formula of the average which we are working out, the arithmetic mean? It is equal to the assumed mean, which is a, plus sigma fd by n. Okay, so in this way we can calculate arithmetic mean when we are having a frequency distribution. So you can see there are some classes given and frequencies are given. So it is a frequency distribution. Okay, now we move to some more examples. The same problem can be done in this way also when we have a step deviation method. And you can see here, instead of 20 to 29, we have taken 19.5 to 29.5 to make it continuous. Again from 29.5 to 39.5. So this is another way of doing it. Whichever way you feel like you can do. This also is quite easy. Once you know the midpoint and once you have found out the deviation, this becomes easy. Here also, using the step deviation method, you can arrive at the same answer. There will be same answer. Okay. Now, Ajitavo is asking a question. We have to divide the deviations by class length and then multiply the frequencies. Now, if you do the step deviation method, then you can use the with the point which you are talking about. For example, here, if you divide minus 30, the deviation, by the class length. Okay, here the class length, you have to make it continuous first. The class length ultimately, if you see, will be 10. Okay, because we are making it continuous, 19.5 to 29.5. So the class length will be 10. So instead of minus 30, then the new deviation, the new d dash will be minus 30 by 10, that is minus 3. I'm writing within a circle. Then if you take the next one, minus 20 by 10 minus 2. Minus 10 by 10, it will be minus 1. 0 will remain as it is. This 10 will become 1 and this 20 will become 2. If you use the class deviation method, step deviation method. Okay. Otherwise, you can do the simple working process which we have shown. Okay, question from Kami again. In exams, shall we get sufficient rough sheet to solve, as it is not possible without calculation? Yeah. So if it is MCQ, see, for MCQ, you definitely have to work out. It's not that MCQ can be handled only through your mental. It's not mental mathematics. So you have to also write. You have to work out. So you will be getting a rough sheet, which will be supplied so that you can do the working out. That is definitely required. Okay. Now missing frequency. Some people were asking about missing frequency. Here we are. Yes. Shiva, you have taken 44.5. Yes, if you take 44.5, what will you get? If I take 44.5 as the assumed mean, you will get the same answer. Because in case of 44.5, if you take as assumed mean, then here it will be 0. 44.5 will be 0. So here it will be minus 20. Instead of minus 30, it will be minus 20. 34.5, it will be minus 10. Ultimately, you will get the same result. Any number can be taken. Any of these mid values can be taken as assumed mean. No problem. Achha, now please be very, very careful. We are handling a question on missing frequency in arithmetic mean. So let us see how to handle these type of questions. Please note, in this given problem, arithmetic mean of the following frequency distribution is given. AM is given, but one of the frequency is not given. Okay, so what is the frequency? So you can see that here the frequency is not given. F3 is one particular frequency which is not given, but you know the entire frequency, the average you know. So how to tackle this? Okay, so let us try and work it out. So I'm writing this question and I will request you to write it with me and let us try and solve it together. Of course, this is a equation. You will find that we have to create an equation. So I'm just writing the height and frequency. So we have the height and we have the frequency 61, 64, 67, 70 and 73. So this is the height and the frequency is given 15, 54, F3, 81 and 24. Okay. Now the average is given as 67.45. The average is given 67.45. Average, please note, is given. I'm writing the average is 67.45. This is given in the problem. So how to tackle this? So in this case, what we will do first, let us use the same finding the missing frequency when we get this type of problems. In a frequency distribution, you may get one or more frequency which is missing. Okay. So you can find out the frequency once you know the overall, once you know the total average. When you know the average of the total numbers, all the numbers, then you can find out the missing frequency. So we are first handling, we will take two types of example. One, the first one is how to handle single frequency, and then we will see how to handle two frequency, which are missing. One missing frequency and two missing frequencies. Now for one missing frequency, so we use the step deviation. Okay. So here we will take 67 as assumed mean. So I'm writing the deviation d equal to x minus a. Okay. X minus a, x minus a. 61 minus 67, that gives you minus 6. 64 minus 67. Please note, assumed mean I have circled. This is 67. So I'm getting minus 3. 67 minus 67 is 0. 70 minus 67 is 3. And 73 minus 67 is 6. Now I will find out d dash. Okay, I am taking d dash. Okay, d dash. I'm using this, I'm solving this using step deviation. So we can see that the classes here we are taking 3. So therefore the step deviation, once we take the step deviation, it can be d by 3. Okay, so I'm taking d divided by 3. So minus 6 divided by 3, I'm getting minus 2. Minus, minus 6 divided by 3, I'm getting minus 2. Minus 3 divided by 3, I'm getting minus 1. 0 remains 0. 3 becomes 3 divided by 3, that is 1. 6 becomes 2. Now I will multiply f and d dash. Okay, so I will multiply f and d dash. 15 is the frequency. D dash is coming to minus 2. So 15 into minus 2 is minus 30. 54 into minus 1 is minus 54. F3, please note, F3 into 0 is 0. And then we have 81 into 1. 81 into 1, kindly note. So just try and write it out with me. 81 into 1 is 81. And 24 into 2 is 48. Now you have to find the total value. So just work it out. It will come to 45. Okay, it will come to 45. So now we have got one missing frequency. Okay, one missing frequency. Now we will use the formula. Okay, so we are going to use the formula. So we have got, this is sigma fd dash is 45. So I'm just rubbing all these parts and we will focus on the solution. So we can write the mean is equal to average mean, assumed mean plus sigma fd dash by n. And that is equal to 67.45, which is given. 67.45 is already given in the problem. Okay, so this is 67.45. Assumed mean is how much? 67 we have taken. Plus sigma fdn. Sigma fdn is 45. 45 by n. Okay, now if you see what is the value of n, the total frequency value, how much? How much is that? Okay, now the total frequency value, if you see, it is 174 plus f3, because f3 is not known to us. We don't know f3. So I can write 45 divided by 174 plus f3. But since we have divided by the class interval, we have to multiply again by 3. So this whole should equal to 67.45. From this equation, which I have written on the board, 67 plus 45, which is sigma FD dash, divided by the total frequency is 174 plus F3 into 3, which is the class interval. So you are getting, you can just work it out, and you can see in the slide also, you can see that you are getting the answer comes to the F3. The frequency F3 is coming to 126. Okay. We are dividing by 3 here because we are taking the class interval as 3. If you see the problem, once again, you will find 61 to 64, 64 to 67, 67 to 70, 70 to 73. So we are taking the class intervals as 3. 64 minus 61 gives you 3. Okay, that is why we are taking the class interval as 3. Okay, now there is one question from Kashish. Will the assumed number be given in the question or the test? No, you value as your assumed mean, no problem. Okay. Now we will take two missing frequencies. Please look at the slide. We are taking two missing frequencies. The aim of the following distribution, arithmetic mean, is given. We are trying to find out there are two missing frequencies. You can see one is F1, the other is F2. Two missing frequencies, and we are trying to solve it. So here again, the number of accident is given, number of days is given, and the arithmetic mean is given 1.46. So first what we do, we have the value of X, number of accidents, number of days. So we are taking assumed mean. We are taking 2 as the assumed mean. So if you take 2 as the assumed mean, 0 minus 2 is minus 2. 1 minus 2 is minus 1. So here 2 is the assumed mean. In this way, you can get D. And then you have frequencies given 46, F1, F2, 25, 10, and 5. So we use the second, we just multiply frequency multiplied by the deviation. Deviation is D. So F into D. So here first F is 46, deviation is minus 2. So on multiplying, we get minus 92. Then again, F1 into minus 1 is minus F1. F2 into 0 is 0. 25 into 1 is 25. 10 into 2 is 20. And 5 into 3 is 15. So sigma FD, we are getting this column. And it works out to minus 32 minus F1. And then once you have the sigma FD, we just put that in the formula. So 1.46 is already given as the average. This is equal to what? 2, which is the assumed mean, plus minus 32 minus F1 by 200. Please note here, we are not multiplying by the class interval. Why? Because in the deviation part, when we were calculating the deviation D, we did not divide by the class interval. So no need to multiply in this case. So solving for this equation, we arrive at the value F1 equal to 76. And if F1 is 76, F2 comes to the total frequency, we can see is the total frequency already we have got. So we can get the once you have the value of F1, we can easily get the value of F2. So it comes to 38. In this way, we can handle two types of missing frequencies. Okay. Okay, now I think it is clear. Nikita, I hope you are clear why we divided by 3 in the last example, because the class interval we took as 3, right? So we have done the important formula in which we need to know in case of the assumed mean, how to use assumed mean, and for single frequency, that is for ungrouped as well as for grouped. Grouped means, of course, frequency distribution. Okay. Now let us take this example, problems on wrong working in AM. This is another type of problem which can come in the exam. Okay. Wrong observation in AM. Let us see the problem first. Okay. The mean of 20 observation is found to be 40. Okay. Later it was discovered that there is some mistake. So how to calculate the right average or the right mean? So there was mean of 20 observation. Okay. So the AM of 20 observation is found to be 40. Number of observation is 20. Please note. Later on, it was discovered that a marks 53 was misread as 83. So the correct marks is 53, but the wrong mark is 83. we have to find the correct marks. Or the correct marks means here the correct, the average. Okay. So what we will do is, we know that arithmetic mean is 40 and n is 20. So the total is 40 into 20, that is 800. 40 into 20, that is 800. This is the total. 800 is the total, that is sigma, you can say sigma fx, that is 800. When we divide it with the number of observations n, we are getting the score of 40, average score of 40. This is nothing but x bar, that is average score. So this is 800. But out of this 800, there is an observation which was noted incorrectly. It was noted in a wrong way. The marks should have been 53, but it was noted as 83. So the adjustment which we need to do, I'm writing ADJ. Adjustment will be how much? 800. From 800, we will deduct 83 because 83 was wrongly entered. And now I will add it with the correct marks, which is 53. So in this example, if you look at this adjustment, 800 minus 83 plus 53. So this gives me how much? It gives me 770. 770 divided by the number of observation 20. So I'm getting the correct average x bar dash equal to 770 by 20. So I'm getting 38.5. This is the right or the correct average which should have been calculated earlier. Okay. So please note here again, in this case, there are 20 observations which are, once again I'm explaining, one of you have written, once again I'm explaining, 20 observations are there and the average is 40. So average is 40 and there are 20 observations. So first we are doing what we are doing, we are trying to find out the total marks, the total sigma fx. By multiplying, we are getting sigma fx, 800. Now there is, the problem states that there is one person's marks which have been entered wrong. So instead of 53, it was entered as 83. That means it has been added 2 more. I mean, it has been over and above the correct marks. So extra marks have got added. He actually got 53, but the marks have appeared as 83. So first you need to deduct that wrong marks. So from 800, we are deducting the wrong value 83. And then we are adding the right value 53. So in this way, we are getting the adjustment is 800 minus 83 plus 53, which gives us 770. And 770 means this is the actual grand total. Number of observations will be the same, 20. So, and you know the new grand total is 770. So from this, you can get the average score, which comes to 770 divided by 20, which is 38.5. Okay, I hope it is clear now. Yes, many of you have got 38.5. Ajitavu and Bhumika. Good. Okay. This one also you can see. AM of 5 observations is 6. After calculation, it has been noted that observations 4 and 8 have been taken in place of observations 5 and 9. Find the correct AM. So this type of questions very common for you to expect in the exam. And this is, you see, not a very tough problem because there is no long calculation. You don't have to create any table also. So here it is given that AM of 5 observation is 6. So the AM, that is x bar, equal to 6. Number of observation is 5. So the total is 5 into 6, that is 30. Fine. That is sigma. I can say sigma x is 30. It is 30. Just a moment. Yeah, it is 30. Now the question is, this is wrong, but this is wrong. Why? Because instead of considering 5 and 9, the observations 4 and 8 have been added. So 4 and 8 is the wrong observation. W stands for wrong observation, 4 and 8. Correct observation, C for correct, it is 5 and 9. So what to do? You have to deduct the wrong observations and then you add the right observations. That is what we do. So here, this 30 is what? The total, sigma x. From here, I will deduct the wrong observation. So I will deduct 4 plus 8. And I will add the right observations, that is 5 plus 9. So I am getting the adjustment 30 minus 4 minus 8 plus 5 plus 9. So the total, if you see the adjusted total comes to how much? 32. 30 minus 12, that is 18. 18 plus 14, that is 32. So 32 is the corrected total. So now instead of 30, I'm cutting 30 off and writing 32. 32 should have been the total. The number of marks, the number of frequency is 5. So therefore, the correct average will be 32 divided by 5, which we are getting 6.4. So please see this example and we have solved it. This type of problem can be expected. Okay. Okay. Jyoti, good that you have understood. Bhumika, it is 32 is the total, but then 32 we got, yes, but then you have to, the question is find the correct AM. Find the correct arithmetic mean. So you cannot stop at 32. You have to divide 32 by 5. And 5, you know, is the number of observations, which is remaining same in both the cases. So you are getting 32 divided by 5, 64. Okay, now finally we look at the properties of AM. So algebraic sum of the deviations will always be 0, that we can understand, number 1. And number 2 is if all the observations assumed by a variable are constant, then the AM is also constant. Okay, say for example, I am just taking this example to show you. Let us take a small case. If all the observations assumed by a variable are constant, then the AM is also constant. Let us take this. So say for example, the score of 4 friends, A, B, C, and D. 4 friends are there, A, B, C, and D. They have got some scores in mathematics. Now, very surprisingly, they have got the same score. Say everyone has got 80, 80, 80, 80, 80. So what will happen if all the observations are constant? Okay, then what will happen? They have got a score, say it is constant K, K, K. So if I try to find out the average, okay, if I try to find out the arithmetic mean, how do I find it out? Arithmetic mean is equal to sigma x by n. Here sigma x is how much? 80, 80, 80, 80. That is 320. So I write 320 divided by n. 1, 2, 3, 4. N is 4. So 320 by 4, that is also 80. That means if all the numbers are same, they are assuming the constant figure, any constant figure k, for example, then the average will also be k. Okay, example, very simple. Okay, deviation also is important. I hope you can understand it. The deviation, the sum of the deviations will be 0. Achha, this is very important. You will get problems on this. If there are 2 groups, group of n1 value has the average x1 and the another group of n2 value has the average x2, then the aim of the combined group is how much? So this is important. Okay, let us take some example. We will take a suitable example to understand this. So when there are 2 groups, n1 and n2, group 1 has an average of x1 bar and group 2 has an average of x2 bar. Okay, many of you have got it. Thank you, Chandan, you have said crystal clear. Thank you. 6.4. Many of you have got Pragati, Jyoti, Priyanka, Bhumika. Okay, good. Yeah, Kashish, already it has been uploaded, and I will also upload some additional problems. Okay. Okay. Now let us see this question. This is very, very important from exam, especially for the exam. I am focusing on the exam. So please note the most important areas for the exam. Now, the mean of 2 samples of size 50 and 100 are 54.1 and 50.3. Obtain the mean of the sample size 150 once you combine them. So here we have N1. Quickly let us note. 2 samples. Find what is the size N1. The first sample is 50. The second sample is 100. Okay. What is the average? So I draw a table here. Average X. So I'm writing X, let me take X1. So the average X1 and X2. Okay. So N1 is having the average of 54.1 and N2 is having the average of 50.3. So the combined mean for all of them. So 50 and 100 is 150. If you add up, you are getting 50 plus 100 is 150. So if you need to find out the combined mean, what we will do? We will just take N1 into X1 plus N2 into X2. Okay, so I'll just create one more table, n1. So I'm just writing n into x. Okay, here x you can see the average score, and we know n. 50 into 54.1. So 50 into 54.1, let me just calculate, and we will just write down the values. So 50 into 54.1, 54.1 into 50. That comes to 2705, and we have 10 into 50.3. 10 into 50.3 is, sorry, 100. This is 100. 100 into 50.3. That is 5030. So I'm adding it up. 5030 plus 2705. 5030. That gets me 7735. 7735. So therefore, the combined average, I'm writing the combined, COMB, combined average is equal to 7735 divided by 150. 7735 divided by 150, and the answer is 51.57 approximately. 51.5666. So I'll take it as 51.57 approximately. Okay, so in this way we can handle these type of questions when there is a there are two teams or two groups, each with different AM, and we have to combine them. Achha. Advantages of arithmetic mean, just to understand one or two points. Okay. Naman, I don't know whether permutation combination, I think it should have been done. Permutation combination, it's done, I think so. Okay. Kusum, Ajitavo, Pragati, and there is one more person. Yeah, 51.567. Petladwala, yes, 51.57. Okay. First of all, arithmetic mean, you could see it is easy to understand, simple and easy to understand. Number two, it is all the data utilized. Because when you are doing the calculation for when you are calculating the arithmetic mean, all the observations, you have to add them. Otherwise, we cannot get the right answer. Also, we can compare two frequency distribution by looking at their average mean. For example, if there are two classes, first class, let's say class section A and section B of a class, and you find it's a school which has two sections per class, and you find that in class 10, for example, the average score, the average marks students have obtained in section A is, say, 71%, and section B they have got 78%. So you know that section B is better. How do you say? You can conclude saying that section B has got better performance. Why? Because the average score is higher in case of section B. It is 78% against 71%, which section A people have got. The average score of students in section A is 71%. So arithmetic mean provides a basis to compare two or more distributions. And we don't have to arrange the data. Later on, you will see that in case of arithmetic, in case of median, we have to arrange the data in ascending order or in descending order, but that is not required in case of mean. Disadvantages of mean, yes, it may give considerable weight to extremes. I was discussing about extremes, too high or too low. Just take this example. Now, if it is seen that mean of 26301, okay, 26 and 301 is 103. Why? Because due to the fact that you have taken an extreme value 301, you have considered that the mean, the average is 103, which is much higher than either 2 and 6. So if you have extreme values, in case of arithmetic mean, it will move up and down, right? And say the arithmetic mean you can get a fraction number, and that may give a misleading idea. For example, if it is seen that average number of patients admitted in a hospital is 10.7, well, it cannot be 10.7 patients. You cannot have fraction. So sometimes numbers or the answers which you get through the calculation of arithmetic mean can be misleading at times. So these are the disadvantages. And it can be hardly located by inspection. Just by looking at a frequency distribution, you cannot you cannot tell directly what is the mean. You have to work it out using these formula, which we have discussed in detail. Okay. Let me now go to median. Okay. Now we go into median. Median means middle. Median means middle. So we have completed our discussion on mean. We have looked at the basic concept of mean. Number two is we have understood what is we have seen the first point is the concept of mean. We understood the formula. When we have few numbers without frequency, how to calculate, we saw sigma fx by n. When we have frequency, again, when we have the numbers only, sigma x by n. When we have frequencies, then sigma fx by n. When we are using assumed mean, we have to find the deviation. Assumed mean A plus sigma fd by n, where n is the total frequency. And thereafter, we have understood the process for calculating or computing where we don't have all the frequencies given. That means when there are missing frequencies, one missing frequency and two missing frequencies, we have handled. And finally, if there is a wrong observation in the numbers which are given, how to calculate the correct average, that also we have done. Now, at the end, we have discussed about how to get the, yes, Shiva, good that you have given the combined average, yes. So how to get the advantages and disadvantages of mean. Now we shall be discussing about median after completing mean. Median means the middle value, as simple as that. So if I give you some numbers randomly, let me take some numbers. Median value means middle value. So I'm taking few numbers. I will take 6 numbers. So first I will take 6 numbers, then I will take, okay, first let me take 5 numbers, easy one. Okay, so 7, 3, 6, 2, 9, and say 5. 7, 6, 2, 9, and 5. Now, when you are calculating median, please remember you have to arrange them in ascending order or descending order. Usually we use ascending order. So I will put them in ascending order. Okay, so I will, ascending means from the smallest to the largest. Here 2 is the first one, then I will put 5, then I will, so 2 is gone, 5 is gone, 6, then 7, and then 9. So I have got ascending, so it is going up. Okay, now what is the median? Very simple, median is in the middle. What is the middle one? 6. That is the median, very easy. Okay, so you can see 6 is in the middle. There are 2 numbers to the left, 2 numbers to the right. So this is the median concept. I think it is very easy. Now we will take one more simple example. We will take, this was 5 numbers. Now let us take 6 numbers. So I will take the numbers 8, 6, 4, let me take 9 and 7 and 2. So they are in jumble, going up and down. So I will first put them in ascending order. So I will take the lowest one, 2. 1, 2, 3, 4, 5, 6. 6 numbers. 2 is gone. Then the next highest number is 4. Then I have the next highest number 6. Then the next highest number is how much? 7. And then we have got 8, and then I have got 9. So now if I try to find the middle, which number is in the middle? Well, now you are a bit confused because you will think that there are 2 numbers which are in the middle. 6 and 7 both are in the middle. So in case when there are even number of observation, 1, 2, 3, 4, 5, 6, even number, that means 6 numbers. When we have even number, 6, 8, 10, 2, 4, whatever, then what happens is we will take the average of these 2. So now the median written by ME is nothing but it is equal to 6 plus 7 divided by 2, that is 13 divided by 2, that is 6.5. Okay, so in this way we calculate median. Let us see this example. Median is the middle number in a set of ordered numbers. I think it is clear now. And I am taking an example you can see on the slide, 1, 3, 7, 10, and 13. So the median is 7. Okay, the median is 7. And you can see the 10 and 13 is on the right hand side, 1 and 3 on the left hand side. So median comes to 7. Now, if I take the next point, and that is median is positional average. Please note, it is positional average. It depends on the position. That means, please note a very important point. Instead of 9, if I put 70 here, instead of 2, if I put minus 50, extreme scores, please note, in spite of that, the median will remain the same. So the median is a positional average. Please note, it is a positional average. It does not depend on the extreme values. It does not depend. Okay. Many of you have got Priyanka, Kamalakshi. Thank you for answering. Median is 6.5. Yes, yes. So therefore, here you can see that here we don't have the need to carry out any type of change, because here even if you have, there's no need to change the median, because even if you have extreme values, the median will not be affected due to any extreme value. That is why it is called positional average. So it is the middlemost. If you see in the slide, middlemost value when the observations are either in ascending or descending order. Please remember, since it is a positional average, you must either put them in ascending or in descending order. Otherwise, the computation, the calculation will be wrong. Please put it either in ascending order or in descending order. For practical purposes, we try to put it in ascending order. So median divides the observations into two parts. I hope you will agree. Like 6 and 7 is these two median values. So it divides the observations into two parts. Left hand side we have say we have taken minus 40, 50 and 4. Right hand side we have taken 8 and 70. So it is always dividing it into two parts. Not affected by extremely large or small observation. I think you can easily understand now. Please see the last point in the bullet point in the slide. Not affected by large or small observation. Even instead of 4, if I write 15, instead of 8, if I take this as 37, will the median be affected? Answer is no. The median will still be 6 and 7. But if I am asking you to calculate the mean, the average, the arithmetic mean, then it will be affected. Then you have to calculate once again because new numbers have come. But for median, there is no change. Median just depends on the position, the positional average. Therefore, you have to be careful either to put these numbers in ascending order or in descending orders. So you can see the median is nothing but an average of position. Median is the middlemost value of the observation. So please keep it in your mind, note it in your mind that median means the midpoint. Median means the middle value. So let us see this table, which you can see in the odd number. So there are number of, you can see digits, 23, 21, 18, 16, 15, 13, and so on. So the first example, if you see, the median is 12 because it comes in the middlemost. Kindly note that in the first example, the numbers are arranged in decreasing order, not in increasing order, decreasing order. Also in the second example, starting with 40, 38, 35, 33, 32, 30, it is in descending order or decreasing order. But here you can see that the median is the middlemost numbers, 27 and 29. Why? Because it is even number. There are even numbers. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. 14 numbers are there. Therefore, 14 is even. So therefore, the even numbers, 20, since it is even number, so we are taking the two middlemost values, that is 27 and 29. And if you calculate their arithmetic mean, it comes to how much? It comes to 28. Okay, fine. Yes, Kamalakshi, thank you for answering the median. Correct. Many of you have given the right answer. Priyanka, Shiva also. So this is median. Okay, now let us see some. There is only one formula, two simple formula which we need to remember, and we will look at the median formula. Please note, median is not influenced. I hope you can understand. The question may come that dash is not, say for example, affected by large or extreme numbers. Answer will be median. Okay, mean will be affected by large numbers. Okay, so here these observations are there. 7 students, they have got observations. Then marks are, you can see, 72, 85, 56, 80, 65, 52, and 68. We have to find their median. So what do? We put them in ascending order, starting with the lowest number, 52, 56, 65, 68, 72, 80, and 85. So then you can see the middlemost value, the median comes to 68 because 68 is the middlemost number. Okay. Now, next one is wages of 8 workers are expressed in rupees. Okay. So what is the median value? Okay, let me just solve this problem. These are the easier ones, and then we will see the frequency distribution also. 56, 82, 96, 120, 110, 82 again, okay, 106 and 100, 106 and 100. So let us first write it in ascending order. So 56 number 1, then 82, again 82. There are two 82s here. Okay. Then you are getting 96, then you are getting 100, then 106, 110, and 120. So 1, 2, 3, 4, 5, 6, 7, 8. 8, we are getting 8 figures. Okay. So how to calculate the median? We just find out the median. So yes, mean you can calculate now using the formula sigma x by n. Okay. So here again, what we do in order to calculate the median, there are 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 figures are there. 8 numbers are given to us. Median means the middlemost value that we know. Middlemost value. So we will just take the middlemost value. 1, 2, 3. These two, 96 and 100. So if you take the average of 96 and 100, you get 98. So 98 is the median. Okay. So please note, for simple data, now we have to remember just a simple rule which will be helpful for your calculations, that when we have individual observations, the median will be taken as the n plus 1 by 2. Okay, n plus 1 by 2. So the n plus 1 by 2, 2th term, this will be the location of the median. This will give us the location, not the median value, but only the location, not the magnitude. That means here when we have these values, first, second, third, fourth, fifth, sixth, so n plus 1 by 2 gives us the location, where will be the median, right? So this is for the location. Now let us see this example. To find the median of the following marks, 4, 12, 7, 9. Okay, we will do it. The solution is there, but let us try and do it and then we will check it. 4, 12, 7, 9, 14, 17, 16. I will first arrange it. So lowest is 4. Okay. Then you can see the next number is 7. 4, 7, 9. 4, 7, 9. Then you have 6, 14, 16, and 17. Okay. So 14, 16, and 17. So there are 1, 2, 3, 4, 5, 6. 1, 4, 12, 7, 9. 4, 7, 9, 12. Yeah, in the middle we have 12. So 7 digits, 7 numbers are there. So we have n equal to odd number, 7. Here n is 7, odd number. So we have to find n plus 1 by 2. This will be the location. This n plus 1 by 2 will be the location. N is 7. So 7 plus 1 by 2, that is 8 by 2. 8 by 2 means 4th, the 4th number. So therefore 1, 2, first, second, third, fourth. 4th number is the median. Okay. So in this way we can calculate n plus 1 by 2. This is in case of observations which are given like this. So we will take the 4th. Please note this number which I am getting, 8 by 2, 4. 4 is not the value. 4 is not the value. 4 is the position, 4th position. So first, second, third, fourth. 4th number is 12. Okay. Now we will look at direct series or simple frequency distribution. So let us look at the problem which is given. For cumulative frequency, we have to calculate the cumulative frequency. Otherwise, we cannot find out the median. Okay. So for median, we have to calculate the frequency, which is the cumulative frequency. Yes, 12 is the median. Thank you, Bhumika, Priyanka, Komalakshi, Mansi, Shambhavi, Shiba. Thank you. Yeah, also Chandan has worked it out. Good, good. Okay. So For direct series, just have a look at the table which is given. So what we do is we have to first find out the formula. We have to understand this working out first. So x is given and y is given. So x is basically, you can see the values 1, 2, 3, 4, 5, 6, and here for the frequency is given f 7, 12, 17, 19, 21, and 24. The frequencies are given. So we have to work out the cumulative frequency because we need to know the location of the median. So let me work this out and then we will understand the process. So first is x. So I'll write x, observation 1, 2, 6, 2, 3, 4, 5, 6. Now we have the frequency f. Frequency is 7, 12, 17, 7, 12, 17, 19, 21, 24, 19, 21, and 24. I will now calculate the cumulative frequency CF. 7 will remain 7. Next frequency is 7 plus 12, so 19. Third frequency is 19 plus 17, so it will become 36. 36 plus 19. The fourth frequency, cumulative frequency is 55. 55 plus 21. 55 plus 21 is 76. 76 plus 24 is 100. So the total is 100. So n is equal to 100. N is 100. N is 100. So we have to find out the location of the median. Okay. So the value, what will be the location? Value of the n plus 1th item. So n plus 1 by 2. This will be the position. N plus 1 by 2. So that is how much? N is 100. So 100 plus 1 by 2. That is 50.5. Okay. So 50.5. This will be the median location. So here we can see 50.5 means we can take it like this, that from 37, okay, so from 37 to 55. So we can say that the cumulative frequency we have got. So 50.5 is greater than the cumulative frequency of 36, but less than 55. So 50.5 will be somewhere between 36 and 55. In other words, it should be around 55. You can see frequency 55 is for 4. Cumulative frequency 55 is for 4. So we have got 50.5. So ideally the median comes to around 4. Now let us see one more example. So this, please note this calculation which we have done, 50.5, this is the position. Here is the position. Okay. Now let us look at the formula which we use. Find the median and median class of the data given below. So let us look at the working out and then we will tally it with the answer. Okay, so this is a small simple formula which we need to know for finding out the median when you are getting this type of class boundary. You can see 15 to 25, 25 to 35, it is continuous. There is no break, it is continuous. It is not discrete. Discrete, if it was discrete, then it would have been something like this, say 15 to 24, 25 to 29, 30 to something, 34, like this. Okay, so this is nothing but, okay. Oh, Vinayak Pawar has written, Vinayak, your student from previous batch, I passed my CA foundation. Very good. Excellent. Very good. Congratulations to Vinayak Pawar for passing the CA foundation exam, and thank you for coming to the class here and informing me. I'm so happy. Very good. Very good. Okay. Now, okay. Now let us see the median and the median class. Okay, Kaushik, 100 is even. We are using n plus 1 is not just for even or odd, it's a general formula. Okay, n plus 1 by 2. Now let us try to find out the median and the median class of the data which is given here. So we will try to solve it. Class boundaries are given and the frequency is given. So in case of median, step number 1 is quickly you have to calculate the cumulative frequency. Okay, so 15 to 25, 25 to 35, 35 to 45, 45 to 55, and we have 55 to 65 and 65 to 75. Fine. The frequency F is given. So we are taking 4, 11, 19, 4, 11, 19, 14, 0, 2, 14, 0 and 2. Now we will find cumulative frequency. You know cumulative frequency means to add up. So first one is 4. For the second class, it will be 4 plus 11, that is 15. For the third class, it will be 15 plus 19. 15 plus 19 is how much? 34. 34. For the fourth class, it is 34 plus 14, that is 48. For the fifth class, it is 48 plus 0, it remains 48. And finally, 48 plus 2, 50. So the total is 50. Fine. The total is 50. Now what we will do, the total is 50. Now in case of class, when we have these classes, instead of n plus 1, the rule is nth term. When you have these class frequencies, frequency distribution. So here we can see n is 50. So n is 50. So 50 by 2, that is 25th term. Now 25th term means what? 25th term means that somewhere here, 25th, that means it is between 15 and 34. So I'll write 25 here, which means 15 and 34, it means the median class is 35 to 45. The median class becomes 35 to 45. So please note the formula which we are using. The formula will be like this. We will take 35 as the median class. So the formula is 35 plus this number, which is the value which you have got, 25th number. This 25 minus 15, the lower cumulative frequency, divided by 34 minus 15. 34 minus 15. That is cumulative frequency of the median class minus the cumulative frequency of the preceding class multiplied by the class interval. Here the class interval is 10. So we are getting 35 plus 25 minus 15 is 10. 34 minus 15 is 19. So it comes to 35 plus 100 by 19. 35 plus 100 by 19, that is around 40.26. Answer is 40.26. Okay, so please note in this case, what we have done is we are just looking at, nth term. Total is 50. Nth term is 50 by 2, 25th term. 25th term, how to find? 25th term will be here in the cumulative frequency. So you can see here the cumulative frequency for second table is the second class which is given is 15. For the third class, it is 34. Now we have got 25, the 25th position. That means it is between 35 and 45. So the median class is 35 and 45. 35 to 45 is median class. And the formula will be 35, which is the lower limit of the median class, plus 25, which is the position. 25 minus 15. 15 is the cumulative frequency of the preceding class, divided by 34 minus 15. 34 is the cumulative frequency of the median class, minus 15 into 10. 10 is the class interval. Okay. So in this way, we can do it. Yes, 35 to 50, 45. Okay. Median is 40.263. Yes, good. Okay. Now we take discrete group frequency distribution. So in the last one, it was continuous. Please note it was continuous. Please see continuous. 15 to 25, 25 to 35. No break. It is continuous. But now we will see there is some grouped. This is a discrete frequency. So in this case also, we have to find median class and median. So here we will just create 10 to 19. We will take it as 9.5 to 19.5. This difference, only this difference. So I will solve this also, and please see step by step, and we will try to go to the last part of the discussion. After this, we will take few questions from MCQ, and we have to understand the last concept, that is percentile, decile, and quartile, of course. So 62 students are there in all, and the marks are given 10 to 19. So I will just directly write the I will make it from discrete, I will make it continuous. So 10 to 19, I will make it 9.5 to 19.5. Again 19.5 to 29.5. 29.5 to 39.5, then 39.5 to 49.5, then 49.5 till 59.5, and 59.5 to 69.5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, fine. Now we have the frequency. F frequency is how much? 5, 8, 14. 5, 8, 14. Okay. 20, 11, 4. 20, 11, and 4, total is 62, which is given. Okay. I will find the cumulative frequency. Next step, please work with the cumulative frequency calculation. 5. Second class, 5 plus 8, 13. Third class, 13 plus 14, 27. 27, the fourth class, 27 plus 20, that is 47. Fifth class, 47 plus 11, that is 58. And sixth class, 58 plus 4, that is 62. Okay. Now we have got 62 students here. So we will take the n by 2. Okay, the nth term by 2. So n is 62. N by 2 is 31. 62 by 2 is 31. So we have to hunt for the number 31 here. 31th number. So 5, 13, 27, 47. 31 is somewhere here in between. Between 27 and 47. 27 and 47 means what? The median class is this one. 39.5 to 49.5. This becomes the median class. 39.5 to 49.5 becomes the median class. Okay, and you can see the median is somewhere here. So the formula will be what? We will take the lower class interval. In this class interval, the interval is from 39.5 to 49.5. We will take the lower one, 39.5. Okay, plus the median position is 31. So I will take 31 in the numerator minus the earlier cumulative distribution, the cumulative frequency of the earlier class, 27, divided by 47 minus 27. 47 minus 27 multiplied by the class interval. Here the class interval is 10. So I'm getting 39.5 plus 31 minus 27 is coming to 4, divided by 47 minus 27 is 20 into 10. So 10 2s are 20, 2 2s are 4. It comes to 41.5. This is what I'm getting. Let me just try it out and check the answer. Okay, the answer is 41.5. Okay, so we have done the median formula. Okay, so we are getting, yeah, I took the decimal. Komalakshi, I took the decimal because we have to make it continuous. Please see the number is 10 to 19. Okay, so we took the decimal because 10 to 19 means it cannot be more than 19. Okay, 10 to 19 is given. So we are taking 19.5. So that means the students are between 10 to 19, but I have increased it. I have gone 0.5. The class limit, you know, we discussed in the first class that when you have the class limit like this, so the upper class limit will be 19.5. Okay, 19, sorry, the 19 plus it will be basically, we have to consider the gap, upper class limit plus it will increase by 0.5 in this example, of course, because we are calculating the upper class boundary from the upper class limit. Okay, so we are trying to make it continuous. From discrete, we are trying to make it continuous. Okay, so in this case, 19 is given and 20 is the next class. So please note, the original class was 10 to 19 and then 20 to 29. How do we calculate? How do we are getting this fraction? So please note, 19 is the upper class limit which was given originally. Plus, we have to take the difference of this 20 minus 19. So 20 minus 19 by 2. Okay, 20 minus 19 by 2. So the formula will be upper class limit plus 20 minus 19. That means the lower class limit of the next class minus 19 by 2. So 20 minus 19 by 2 is 0.5. So we are getting 0.5, 19.5. Okay, this we had discussed earlier in the first session about how to find out the class boundary from the class limit, because in class boundary it will be basically continuous. You can see it is continuous now. So in this way, we are arriving at 41.5, which many of you have got good. Dhyanesh, Shambhavi, Shiba, Mansi, Mohammad Ahmed, Bhumika. Okay. Okay. Now, so we have done this incomplete frequency distribution. Now we will take the last example, incomplete frequency distribution. So here you can see 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 is given, but we don't know the frequency. For one particular class, frequency is not given. So we will try to solve it. So I'm just rubbing this part and I will try to solve the problem, and you will definitely understand how to handle missing frequency. So here we have the marks are given. So the same process, 10 to 20, it is continuous. Please note it is continuous, nothing to do here. 30 to 40, it is not discrete, it is continuous. 40 to 50 and 50 to 60 is given. Okay, number of students, 3, 5. Then there is a gap. So I'm just circling it, 3 and 1. Okay. So let me assume that this frequency is f. Okay, so I will now calculate the cumulative frequency. 3 plus 5 is 8. 8 plus f is f plus 8. F plus 8 plus 3 is f plus 11. And here we have f plus 12. Okay, so it is f plus 12. This is the total frequency. N, capital N is f plus 12. It is given that the median is 32.5. So you can easily understand if the median is 32.5, then the median class is this one, because it is given median is 32.5. Okay, so we will take the formula. For calculating the formula, we will first take 30 here plus. Now we have f plus 12 is the total value of n. So position will be how much? It will be f plus 12 by 2, because the formula is n by 2. So that means f plus 12 by 2, this is the position. So this f plus 12 by 2 will be somewhere here. So the formula will be 30 plus f plus 12 by 2 minus 8. 8 is what? 8 is the cumulative frequency of the preceding class, minus 8, divided by f plus 8, which is the frequency of the median class, minus 8. So it will be f plus 8 minus 8 multiplied by class interval. Please note the class interval is 10. It's all the same, continuous, 20, 20, 30, 30, 40, 40. Class interval is 10 into 10. This calculation which we have done should be equal to 32.5. It has to be equal to 32.5. Okay. Yes, n plus f. Yes, Shiva. Yes, total n is 12 plus f. F plus 12. Yes, correct. You have achieved the correct. You have arrived at the correct figure here. So 30 plus, I'm just rubbing this portion now because we have completed using this portion. Now we are getting 30 plus f plus 12 by 2 minus 8 in the numerator plus divided by f plus 8 minus 8 into 10. So this gives me 30 plus f plus 12 by 2 minus 8. How much is that? It will come to f plus 12 minus 2, 8 is 16. Remainder will be 2. And here I am getting 8 and 8 cancels. In the denominator, it is 2f multiplied by 10. This is equal to 32.5 because in the numerical, it is given that the median is 32.5. It is given in the numerical. So what I will do, let me try to simplify. 30 plus f plus 12 minus 16 gives me f minus 4 by 2f. Okay, into 10. This is equal to 32.5. So from here, I will subtract 30. So 30 goes to this side. So it becomes only 2.5. So let me just work out the last portion of this numerical. So we have f minus 4 by 2f into 10 equal to 2.5. So 2.5 will go here 4 times. That means I'm getting f minus 4 by 2f into 4 equal to 1. So 2 and 2 cancels out. So by cross multiplication, I am getting f minus 4 is equal to 2f. Okay, f minus 4 equal to 2f. Just a moment. Let me just check whether things have gone correct or not. 30 plus f plus 12 minus 16. Okay, f plus 12 by 2 we have taken, perfect. Okay, so just let me check. F plus 12, just do it once again, this portion. F plus 12 by 2 minus the cumulative frequency was 8. So that divided by, we had got, the denominator was f plus 8 minus 8. So we had 2f here because we are getting f plus 12. This is f plus 12 minus 16 by 2. And in the denominator, we are getting 8. So 2f into 10. Okay, that is equal to 32.5. So here we are getting 2.5 f minus 4. And therefore, f should come to 8. Okay, so f should come to 8. So we have here, if you look at the calculation, we will get 2.5 equal to 10 by f3, which we had got. We had taken this as f, the last portion. 32.5 is equal to f plus 12, that is f plus 12 by 2. So cumulative frequency is 30 plus f plus, we had got by 2 f plus 16. Sorry, just a moment. We'll just take the total amount. Once again, we will just try and do it. So 3, 5 dash, we'll take it as f, 3 and 1. Cumulative frequency comes to 3, 5, 3, 8, f plus 8, f plus 11, and f plus 12. Total frequency is f plus 12. So we will take n by 2 as f plus 12 by 2. F plus 12 by 2 is the midpoint. It is basically the median position. And therefore, we know for f, the frequency is, the class boundary is 30 to 40. This is known. And we also know that 32.5 is the median. So we are taking f plus 12 by 2 as the midpoint. So therefore, what we are getting is the median class will be 30 plus 30 to 40 is the median class, 30 plus this number minus 8. So f plus 12 by 2 minus 8 divided by the cumulative frequency of the median class minus the previous. So f plus 8 minus 8 and multiplied by the class interval 10. So what we will get if you solve it out, so a plus 8 and minus 8 goes out, we get f here, and here we are getting f plus 12 minus 16 by 2. So we are getting 30 plus f minus 4 in the numerator, and in the denominator you get 2f multiplied by 10. This is equal to 32.5. So f minus 4 by 2f into 10. F minus 4 by 2f into 10 will give you 2.5. So just do it here. F minus 4 by 2f, this multiplied by 10 will give you 2.5. From here, if you just calculate, you will get, this is 2.5, sorry, 2.5. And therefore, if you just calculate, you are getting, if you just cross multiply, you will be getting the answer. And you will get f equal to 8. Just cross multiply from here, and the last portion you will get f equal to 8. So in this way, we can get the missing frequency. And finally, the median advantages and disadvantages. Median we can see is unaffected by extreme value. That is the first part of it. It is not affected by extreme value, and it is easy to calculate, simple to understand, because it is a positional value. We know that, okay, if n by 2 or n plus 1 by 2, so in case of group frequency distribution where we are having class boundary, and when we have classes, it is n by 2. But in other simple cases, when you have the simple observation, it is n plus 1 by 2. That gives you the position of the median. It is not the value, but the position of the median. So it is easy to calculate, and it is basically positional average. So even if there are extreme values on the other side, on the two sides of the median, it does not make a difference. Median will be the same. It can be located by inspection, but we remember that we have to arrange these numbers in ascending order or in descending order, that is in order of magnitude. It can be determined graphically as well. And disadvantage will be number one, it is necessary to arrange the data. In case of average, mean, arithmetic mean, you don't have to arrange. But in case of median, you have to arrange. Number two is median cannot be used to calculate combined median. In case of mean, we have already done the numerical. If N1 number of observations has mean X1, and if N2 has mean X2, then the combined will be N1 plus X1 divided by N1 plus N2. That gives you the combined mean. But there is no such formula for combined median. Please note that there is no such formula. And it cannot be computed precisely when it lies between two items. As you can see, we know that the median is between 30 to 40, but you have to calculate details, then only you can reach the median. And finally, median is affected more by sampling fluctuations than the mean. So that, of course, is there. Now, the last property of median is very simple. If x and y are two variables such that y is equal to a plus bx, in that case, the median y-me will be a plus bx into me, bx, that is bx-me. So let me just take this example here. So let us assume that 2x minus 5y equal to 10. 2x minus 5y is 10, it is given. And median of x is 16. So I'm writing x-me is 16. We have to find y-me. Y-me we don't know. Median of y we have to find out. X is known, but y is not known. How to do it? So if you try and solve this, we are getting 2x minus 5y equal to 10. Okay, 2x minus 5y equal to 10. Now we will put it in form of y. So we can write, we can just interchange like this. 5y will be equal to 2x minus 10, or we can write 5y equal to minus 10 plus 2x, or we can write y is equal to minus 10 by 5 plus 2x by 5. Okay, but plus 2x by 5. Now this is equal to minus 10 by 5 means minus 2 plus 2x by 5. Now we know x is equal to 16. So I will just put the median of x is 16. So therefore, when we know that the median, we have to find y median. Y median is equal to minus 2 plus 2x median by 5. So this gives me minus 2 plus 2 into 16 by 5. So I am getting y median. Y median is equal to minus 2 plus 32 by 5. So 32 by 5, just let's calculate and check. So 32 divided by 5 gives you 6.4. 6.4, and you have minus 2 here. So minus 2 plus 6.4. So the answer is plus 4.4. So the answer is y median. Y median is equal to 4.4. This is also very important for the exam because these type of questions already have come in the exams earlier. So this is important. The relation between, when we have a linear relation y equal to a plus bx, and we know the median of x, how to find the median of y. Lastly, we have the partition value or the quartiles. Quartile means basically the first quartile. There are 3 quartiles because quartiles are breaking down the entire observations which you have. Their number of observations can be there, and the quartile means it is breaking up into 4 parts. So you have quartile 1, 2, 3. And the first quartile is the value for which 1/4 of the observations are less than or equal to Q1. So that is called the first quartile. Similarly, you have the decile. Decile means we are breaking the observations into 10 parts. And then you have the percentiles, which means that the entire observations are broken into 100 equal parts. Okay, and in this way, we can calculate quartiles, deciles, and percentiles. We will take one example and we will do it. So now coming to the last part, we will take the examples from the MCQ set A. So looking at set A, yes, 4.40. Thank you, Priyanka. Measures of central tendency for a given set of observation measures what? Number A, scatteredness. Is it the central location? Is it both A and B? Is it none of B? Well, central tendency will always try to find out the central location of the observation. So option B is correct. Next is, while computing the AM from a grouped frequency distribution, arithmetic mean from group frequency distribution, we assume that the classes are of what? Equal length, equal frequency. Well, classes cannot have equal frequency. So option number 2 is not correct. All the values of a class are equal to the mid value of that class. All the values of a class are equal to the mid value. No, this is also not right. So the answer is A. The class has to be of equal length. Otherwise, we cannot calculate cannot calculate arithmetic mean. So for calculating arithmetic mean, all classes are of equal length when we are considering grouped frequency distribution. The presence of extreme, please see this question is very important from the exam. The presence of extreme observations does not affect what? Arithmetic mean will be affected, because if you have an extreme observation, that has to be calculated, that has to be considered for calculation of AM. But for median, we have seen the positional, it is the positional average. So the presence of extreme value either on the lower side or on the upper side does not make a difference. So the answer is median. Option B is right. We move on to the next few questions. Number 16. Quartiles are the values dividing a set of observations into how many parts? We have just observed it is into 4 equal parts. So option B is the right one. Now we move on to set B. If there are 3 observations, 5, 15, 20, and 25, then the sum of the deviation of the observations from their AM is how much? It has to be equal to 0 always. So the mean 15, 20, 25, if you just find out the mean and if you subtract the mean and you find out the deviations from each of the numbers, you will find it is 0. So answer is 0 here. Next one, what is the median of the following observations? 5, 8, 6, 9, 11, 4. We have done this problem already. Options are given. So if you arrange it in increasing order, you will get 4, number 1, I'll just grab it out, just arranging it, and you can just, it's a quick recap of the points we have covered already. So 4, 5, 6, 4, 5, 6, 8, 9, 11, 8, 9, 11. We will take the middle number 1, 2, 3. So the median comes to 6. Okay, 6 is the median. Okay, next one. One, two, three. Just a moment. 5, 8, 6. No, we had 4, 5, 8, 6, 9, 11. 4, 5, 6, 8, 9, 11. 8, 4, 5, 6, 8, 9, 11. Okay, no, 6 and 8. Sorry. So this is, we are taking the middle two. 4, 5, and 9, 11. So 6 plus 8 by 2. That is the average comes to the, we are taking the arithmetic mean. So 7. So the median is 7. Option B. Right answer. Okay, number 8, what is the value of the first quartile for the observations number so and so? So let us just try and do this quartile. So quartile, we will take it as basically n plus 1 by 4. So here we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So quartile will be n plus 1 by 4th observation. Okay, so here n is equal to, please see, how many numbers? 15, 18, 10, 20, 23, 28, 12, and 16. So 8 numbers are there. N is 8. So 8 plus 1 by 4. So 9 by 4. 9 by 4 means 2.25. So this is the 2.25th observation. 2.25th observation. Now we have to find the first quartile. So we have to arrange the numbers in increasing order. So for quartile calculation, you have to just work it out like this. So let me arrange it in the increasing order. We start with the lowest number 10, then we have 12, then 16, and so on. Okay, 2.25 means we will take the second 2. Second number is 2, 12. So we'll take second number plus 0.25 multiplied by the difference of the third number and the second number. So this will be 0.25 multiplied by 16 minus 12. 16 minus 12. So ideally, you can see if you just work it out, we will get the answer. The first quartile. So we have got how many? 9 by 4, 8 plus 1, 9 by 4. So we can get that it will be second term plus 0.25 into the third term minus second term. Okay. So third term, just let us check. We have got 10, 12, 15. No, this is 15. 15 will come here. This will be 15. Why? Because 10, 12, 15. So you have to write in ascending order first. So 10, 12, 15, then 16. So 12 second term plus 0.25. This 0.25. 2.25 is broken. 2.25 is broken into 2 plus 0.25. So second position we have taken 2 plus 0.25 into what? Into the third term minus second term. Second term is 12, but third term is 15. So 15 minus 12. So that will give us 12 plus 0.25 into 3. 0.25 into 3 is 0.75 plus 12. So 12.75 should be the answer. And this means the answer is option number C. The third decile of the numbers, we are just taking the last few questions now. The third decile of the numbers, we are just completing in few minutes. Okay, 4 parts. Yes, many of you are answering, and thanks to all of you. Priyanka, Mohammed Khan, Mansi, Jyoti, Priyanka again, Mansi, Shambhavi, Shiba. Thank you. Just we'll try it out. The third decile for the numbers is what? So please just work out with me. Another 5 minutes will take. You can see it is a long chapter and we have not taken any break. Still it is past 4 already, but we will just complete. This is the last slide and we are completing the important questions from the set A and set B. Third decile for these numbers: 15, 10, 20, 50, 25. So again, we will arrange it in increasing order. 9, 12, 9, 11. 11 will go first. I think we also have 10. 9, 10, 11, 12. 9, 10, 11, 12. Then the next highest number is 15, 18. 15, 18. And then we have 20 and 25. 20 and 25. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 numbers. So for finding out decile, decile means 1 by 10 because there can be 10 deciles. So it will be n plus 1 by 10. In case of quartile, it was n plus 1 by 4. Here it is n plus 1 by 10. N is here 1, 2, 3, 4, 5, 6, 7, 8. So it is 8 plus 1 by 10. That is 9 by 10. Okay, it comes to 9 by 10. Okay, it is coming to 9 by 10. But they have asked for the third decile. Third decile means 9 by 10 into 3. That is 27 by 10 because here they want the third decile. First decile, second decile, third decile. 3 multiplied by 3. So 27 by 10, that is 2.7. 2.7 means it is what? We will break 2.7 into 2 parts. First is 2 plus 0.7. This 2 is what? The second position, second number. Second number is 10. First number, second number. So we take 10 plus 0.7. Now we take the 0.7. So 0.7 multiplied by what? The third number minus second number. Third number is 11. Second number is 10. So the answer is 10 plus 0.7 into 11 minus 10. Third number minus second number. Third number is 11. Second number is 10. So it is 10 plus 0.7 into 11 minus 1. That is 10 plus 0.7 into 1. That is the answer is 10.7. So you can see the option given here, B. Option B is the right one. So we have to arrange in ascending order. Please note. Okay, now the last few questions. If the observations, if there are two groups containing 30 and 20 observations and having 50 and 60 as arithmetic mean, then what is the combined arithmetic mean? Just quickly, let us do it. It came in the, very important, it came in the mock test also. 30 observation and 20 observation. So two groups are there, 30 and 20 n, and the frequency and the means are 50 and 60. So we first calculate fx. 30 into 50 is 1500. 20 into 60 comes to 1200. So total comes to 2700, and the total number is 30 plus 20, that is 50. So the grand average, the mean comes to 2700 by 50. So that is 270 by 5. Let me see the options which are given, and then we can correct the options. 54, yes, 270 by 5 is 54. So option C is right. Two variables x and y are given by y equal to 2x minus 3. If the median of x is 20, what is the median of y? Very similar to this, we have already done. This is the relation of x and y. And if there is a linear relation, so the median of y median is equal to, it is given 2x minus 3. So I will write this minus 3 plus 2 into median of x. 2x minus 3, I have written minus 3 plus first and then plus 2 into median of x. Minus 3 plus 2 into median of x. Median of x is 20. So I will write 2 into 20. That is minus 3 plus 2 into 20, that is 40. So minus 3 plus 40 is minus 37. Minus 37. It is coming to minus 30. Just let us check. Sorry, 37 plus 37. Minus 3 plus 40 plus 37. Yes. So answer options are 20, 40, 37 and 35. So we have got 37. That is, the option is coming to C. Okay, so that's it for today. So we have covered all the areas and we started with the observations of basic observations on arithmetic mean. We understood central tendency, what are the types of measures of central tendency, that is mean, median, mode, and of course within mean we have the arithmetic mean, geometric mean and harmonic mean. And we have completed the discussion of arithmetic mean today, the formula which is used for ungrouped as well as for group frequency distribution, the technique of using assumed mean that we had covered. Then we looked at the properties of arithmetic mean, the advantages and disadvantages, and thereafter we moved into the understanding of median, understanding it from easier concepts. Then we went on to the discussion of the formula which is used for the grouped frequency distribution, how to convert the classes, the frequency classes into the class boundaries, and then how to take use the formula n by 2 or n plus 1 by 2 as may be required. And thereafter we completed the discussion of properties of median. Please remember, median will not be affected by extreme values. And finally, we have calculated the understanding, we have gone into the understanding of the quartile, the decile and the percentile. So with this, we conclude today's session. Thanks for all your support and the interaction. I hope you are understanding the problems, how we are solving the problems, and which one are important. Whatever important questions are there for the exam, we are trying to solve it here. In the next class, we'll meet and discuss about mode, HM, geometric mean, GM and HM. Till then, thank you and see you again.